Our first presentation is going to be Miss Samah, and I'm going to go ahead on and set it up. And as soon as you see your slides come up on the screen, you can unmute yourself and start. And your time will start as soon as your slides come up. So stop that share and do another share. Here we go. And all right. Samah, you can take it away.
All right, so starting with my introduction, why did I choose the Rice University Path Step Young Scholars Program? Number one, Rice University has incredible research opportunities. It is my dream school, and also I fell in love with the purpose of Path Step research, which I will discuss in a little bit. So what was my task in this project? I created an unsupervised machine learning project with the Wisconsin breast cancer dataset. I was honored to work with Bhargav as my mentor and Nima and Tracy as my team members. Bhargav was incredibly helpful and patient. He taught me so much during this research process, and I will discuss that in a little bit. Now, what was the description of the research? The goal of PathStep research is to develop efficient, cost-effective technologies that will provide underserved communities access to adequate healthcare. So here are the 3 clustering methods that I tried in my unsupervised project. On the left, you see density scan clustering with a 62.7% accuracy rate. On the center, you have Gaussian mixture expectation maximization with a 94% accuracy rate, and Gaussian mixture variation inference with a 93.1% accuracy rate. And I will discuss why we have such a large variation in our accuracy rates between density scan clustering and Gaussian mixture. So why did density scan clustering not work the best? Density scan clustering assigns border points to core points, so it makes smaller clusters within a larger data set. However, the breast cancer data set is very dense throughout both clusters, so the model had a hard time picking up on these 2 distinct clusters. Now, Gaussian mixture models fit a mixture of Gaussian models to data, and this is more efficient because it is a probabilistic concept that is effective at representing unknown clusters within a larger data set. And that is the pretty much big reason why Gaussian mixture worked more efficiently. Now, what I learned from Dr. Strack, I learned so much. It was very hard to bring it into one slide. But the main thing is she taught us incredibly how there were different advantages and disadvantages to different algorithms. And since there was only 3 weeks in our program, we could not test every single model. So she gave us all the information we needed as students to choose what kind of model would work well for our data and what would not. For example, parametric models are great for less complex data, but non-parametric models are great for more complex data and are more prone to overfitting. So some pros and cons we learned about on both sides of the story. Now, what some programming coding highlights? We really learned how important it is to prepare and clean our data or pre-process it efficiently. So for example, there's an importance of standardization and dimensionality reduction. These processes reduce overfitting, reduce the time required to run the model, and improve the accuracy of the model. Some functions I used were select k-best, principal component analysis, and standard scalar to see which would give me the best accuracy rate within my different 3 clustering models that I tried in this project. Now, why is this research important? This research showed me that there is an efficient and less efficient model for classifying malignant and breast cancer cases. So for example, I found an efficient model was Gaussian mixture. An inefficient model was the density scan clustering. Now, I'm passionate about research in this field because this research supports the production of efficient software that can improve healthcare access for disadvantaged communities. I believe all people from all backgrounds should have access to adequate healthcare, and this takes a step in the right direction towards helping people have efficient and access to good healthcare. Now, I was interested in the research of Mr. Mella and Mr. Barra, but I was most interested in the research of Mr. Zhao during the Highlights for Speaker series. His research worked on brain-computer interfaces, and his research proposed something called the TOF dot. And that was a method that is able to image deep with minimal reconstruction time. Now, this research has incredible fundamental applications in clinical research, and I was very interested in how well this worked in the software engineering, how it mixed medical, but also brought in that computer science and software engineering background. Finally, I really enjoyed collaborating with my fellow young scholars, even if it was a remote learning experience. Specifically, the unsupervised learning team, Tracy, Nima, and I really supported and encouraged one another during the process. If I ran into an issue, I had these wonderful and incredibly intelligent people to work with, to work out our issues and help one another succeed. And Bhargav, Mr. Antoine, Dr. Strack, and all the other incredible mentors were helpful, informative, and patient during this process and helped me so much during the entire research experience. Finally, my future plans. So I have the plan of getting an undergraduate in biomedical engineering, hopefully at Rice University, my dream school, followed by medical school and then residency and specialization in ophthalmology. In this entire period, I want to learn more about supervised learning algorithms and how I can apply them in ophthalmology. During this program, I worked on unsupervised learning algorithms, and I want to see how supervised learning algorithms could have a different forms of accuracy and see how I can apply that in the ophthalmology field as well. And then this is my final project poster. It shows us the research objective of PATSUP as well as my research objective. Talks about the different forms of clustering as I looked at, density scan clustering, Gaussian mixture, and maximization expectation. And I would like to give a big thank you to Dr. Strack, Mr. Antoine, the National Science Foundation, and the Rice Office of Engagement for this incredible research opportunity. Thank you so much for your time.
Thank you very much, Samah. And even if we didn't, because we were kind of flying through and we're going to fly through with a lot of these presentations. So if anyone has any questions just in general about the research or has any questions about the experience, feel free to ask that. Or if Samah, you have anything else you want to share after your time that you might have felt like you didn't get a chance to say, feel free to do so now as we before we transition to the next speaker.
I think I got most of it, but I definitely flew through it. Like I barely had time to breathe, so sorry about that. But it was definitely crunched.
No, you put a lot into it, and I like that. You went well and beyond. So yeah. Obviously, you guys, the young scholars, you can look at the Jamboard as well. So, but one question we did have is, what was the most challenging part of this experience for you, Samah?
So the most challenging thing, let me think about this. So I think the biggest thing was going into this program, I only had experience in Java. And so going into Python, it was like learning to write an essay in a language I had never written or read before. That was the extent that I had to work with during this program. And so I was very overwhelmed at the beginning. So I think the hardest thing was really just figuring out the functions and syntax of Python, more so than the actual conceptual idea behind machine learning. But I was very fortunate to have Dr. Strack and Pargab helping me out throughout the process. So I'm very thankful to them for helping me get from not knowing Python at all to doing a machine learning project in just a matter of 3 weeks.
It's awesome. It's awesome. So thank you very much, Samah. And without